Yung ating prelim exam would be on Monday, right? March 29. Okay? So, ang time niya is 6 to 8 p.m., no? So, departmental kasi exam natin, so kasabay niyo yung isang section. Okay? Ayan. So, is there any conflict with the schedule, guys? Meron ba kayong subject ng araw na yon? So, Monday, 6 to 8 p.m.
Transmalab.
Okay, laboratory. I think since ano naman, ECE subject din naman. So I think okay lang 'yun, no. Walang magiging problema dun. Alright, kasi nagplot na kami ng mga schedule ng mga exams, no. Ayan. Bagay, ano na nga pala kayo, no? Third year, wala na kayo sa ibang department. Anyway, so game, let's start our discussion, guys. Okay, no? So, our topic, no, for today, no? So, continuation lang to actually nung lesson natin last week, no? So, last week, di ba, we have discussed the reflection, okay? Velocity propagation, yung mga ganun. So, for today, no, we're going to discuss transmission line instruments. And number one, no, sa transmission line instruments, yung tinatawag nating, ano, guys, quarter wave transformer. Okay? So what is a quarter wave transformer? So quarter wave transformer uses a quarter wave section of a transmission line to match a purely resistive load to a transmission line. Okay? Kasi 'di ba, if you still remember, no, ano nga uli ang condition natin para sa maximum power transfer? So for maximum power transfer, ang Z sub O natin must be equal to Z sub L. 'Di ba? So the characteristic impedance of the transmission line must match, no, with the load impedance of the transmission line. Okay, so that's the idea. All right? Now, in most cases, hindi nangyayari yun, no? Okay, in most cases, yung Z sub O natin, hindi siya match, no, sa ating load impedance. Pero, of course, no, we don't want that situation. Ang gusto natin, match sila. So, if that's the case, no, we can use a quarter wave transformer. So, quarter wave transformer is basically a transmission line with an adjustable characteristic impedance, okay, which is basically quarter wavelength long. Okay? We're not gonna derive this formula, guys, pero ito yung ZO prime, ito yung characteristic impedance ni quarter wave transformer. Z sub O is the characteristic impedance of the original transmission line na minamatch mo sa load impedance na Z sub L. But if you're interested, how do we come up with this equation, no? So dito siya galing, guys, no? Yan, dito, no? So sa impedance ng section ng transmission line, saktong lambda over 4 yung length niya. So bale yung L mo, lambda over 4 yung sa substitute mo, and then you just derive, no? So we will be getting this formula. Okay? So ready? All right. So let's answer a question, no? With regards to that. So, a 50 ohm transmission line is terminated with a resistive load of 120 ohms. Design a quarter yan, kamali lang, quarter wave transformer that could be installed at the load to match it with the line. Determine its length and characteristic impedance. Okay, operating frequency is 70 megahertz. Okay, first is yung length muna, no? Yan, mas madali yung length. Okay, so how do we solve for the length, no, of the transmission line described in the problem? So, I mean, the quarter wave transformer. So, yung length niya, lambda over 4. Quarter wave transformer nga eh. Okay, so you just get lambda over 4. So, the thing here is yung pag-calculate natin ng lambda. Okay, so what will be our lambda? Lambda natin ay BP over F. So, yung BP natin ay CVF. So, we have quantity, 3 times 10 to the 8. Okay. So, pag walang given na velocity factor, ang assumption doon is ang velocity factor mo ay 1. Yan, kung walang given, no? So, divided by the operating frequency, which is 70 megahertz. 70 times 10 to the 6. Okay, and then divide by 4 lang. Okay nga, guys? So, can you help me, no? So, what will be the length, no, of our quarter wave transformer? Uy, paki-compute. Wala akong calcu. Okay, so we have 17.14 meters. All right. So, I think pare-pare sa mga nasagot, no? So, yan lalagay natin, no? 17.14 meters. Okay? Yan. Yan. So baka nagkamali ha. Ito muna yung gagawin ha. Bago di-divide by 4. Okay? Iba kasi yung magiging sagot kapag ka ano, no? Right? Okay? Alright. So, next naman natin is yung impedance na mismo, no? So, ano yung impedance niya? So, ZO prime, okay, is simply equal sa square root ng ZO original, which is 50, okay, multiplied by 120. Right? So, anong lalabas, guys? What is ZO prime? What is the characteristic impedance of this quarter wave transformer? So, anong lalabas, guys? Okay, we have 77.46 ohms. Okay. So, ano itsura niyan, no? Ano itsura? So, for example, ito yung ating 50 ohm na transmission line. Bago mo siya ikabit sa load, ikakabit mo muna siya sa isang transmission line na may length na lambda over 4. Okay? Yan. So, this is your ZL. Okay, this is your original na Z sub O. Yan. Tapos ito yung ano guys, no? Ito yung quarter wave transformer may lambda over 4 na length. Okay? So nagets po? Instead na ikabit mo siya directly sa load, you're gonna use a quarter wave transformer. Okay? Basically, this is also a transmission line. Parang extension i-extend mo lang yung transmission line mo instead of, parang adapter ang dating. Instead of directly ikabit mo siya sa Z sub L, ikakabit mo siya sa isang lambda over 4 na length ng transmission line. Depende kung anong klaseng transmission line, no? Kung parallel wire line ba o coaxial cable, so ganun din dapat yung itsura niya. Gets? Kaya coaxial cable yung gamit mo, dapat ganun din yung itsura. Okay? Alright. Pero madalas, no? So, this is used for parallel wire transmission line. Okay. So, o yan. Yun nga eh, nagkamali nga eh, no? Yan yung tinatanong ko kanina eh. Nagkamali ito, no? O, yun nga. So, ang answer natin is supposed to be what? Kaya nagot ako ang haba eh. 1.071 meters. Yung nga sabi ko kanina eh, ang ginawa nyo, ito muna, inuna nyo, alak ka. Di ba ito muna, yung taas muna? Okay? So, yung taas muna bago i-divide by 4. Oh, puro mali lahat eh, no? Oo, ang dami nagsagot kanina, puro mali. Mm. Oo, pag 'di ba lambda over 4 kasi guys, bali ito muna no. Sabi ko na eh, mali eh. Yung taas muna yung ano nyo, isa-solve nyo, lambda over 4 nga eh. Kasi magkakamali talaga. Tingnan niyo, nagkamali kayo. Magkamali kayo syempre pag yung una dinivide nyo, 'di ba? Okay? Sige. Right, no? So let's have the next one. So next na transmission line instrument natin is stub. Okay? So again, the goal is yung characteristic impedance ng iyong transmission line ay ma-match no doon sa load impedance natin. However, okay, you can only use a QWT if your load is purely resistive. Meaning to say, impedance niya is walang imaginary part, walang reactive part. Like this in this example, 'di ba? Yung 50 ohm na transmission line ima-match natin kay 120 ohms na load. Okay, so wala problema 'yon. You can directly use QWT. However, okay, if you have a reactive component sa load natin, okay, we will use a stub first. So what is a stub? That is actually a certain section ng transmission line na ginagamit natin guys to remove the reactive component of a load. No? So gagamitin natin siya para maalis natin yung reactive component ng load natin. Now, pag nagamit na natin yon, naalis na yung reactive component ng load natin, tsaka tayo gagamit ng QWT to match it with the characteristic impedance of the transmission line. Okay? So nagets ba? Kasi in most cases, yung load natin, hindi naman siya purely resistive. no? So may either may inductive part 'yon o may capacitive 'yon. So you need a stub to remove, no, the reactive component sa load natin before we can match it using a QWT. So next natin guys na transmission line instrument is a Smith chart. Okay, so this is whole another new lesson guys. But we will not discuss this in our lecture, no. So mostly dinidiscuss ang Smith chart sa laboratory, no, sa transmission lines. No, so usually dun siya dinidiscuss, no. So ang tawag natin dito, yan, yung figure na yan, that is a black magic circle, no. Yan, that's the name. Oh, black magic circle na Smith chart, no? So, galing ng name niya, no? Parang no? Evil no? Black magic circle. So, yan yung guys, no? Smith chart. Okay? Kumbaga no, instead of solving no, theoretically, gumagamit ng Smith chart in conjunction with compass, no? Yan para makita natin or malaman natin yung mga impedances, SWR, reflection coefficient, no? So that's the idea of using a Smith chart. Again, guys, no, we will not discuss this anymore in our class. If you're in, sa laboratory siya tinuturo, yun. No, so you would know that in your Transmalab. So next natin guys is this is a very interesting device. Ang tawag natin dito is optical time domain reflectometer. Okay? So what's the purpose of optical time domain reflectometer? So halimbawa guys, no, meron kang transmission line. Hindi naman natin maiiwasan na as time passes by, no, either masisira yung transmission line mo, may part doon na masya-short or ma-open. Question, if that happens ba, yung buong transmission line natin papalitan natin? O we will try to repair yung part na short or na open. What do you think sa common practice na ginagawa? Tingin nyo. Kunyari, meron kang transmission line, no? Halimbawa, telephone line, ayan, or telephone cables, ayan. So, may portion doon, guys, na halimbawa na na nasira, okay? So, how would you guys? How would you fix that? Tingin nyo, inaayos ba yung sira o pinapalitan lahat? Tingin nyo, guys. Ano ang ginagawa natin? Hello? Delay ba? Naririnig nyo ba ako? Delay ba? Tingin ko delay no? Parang ang tagal nyong sumagot Okay. Hello? Okay, no? So inaayos. Inaayos 'yun, no? Imposibleng palitan lahat, guys. Imagine, no, yung telephone line isang buong mahaba papalitan mo lahat. Na-imagine niyo 'yun, guys. Oh, 'di ba? Kunyari isang mahabang telephone line, no? Oh, mula mula central office hanggang dun sa poste sa bahay nyo. May part lang na nasira in between. Would you change everything there? Not really, right? Hindi, 'di ba? So you would fix a part na may sira. By the way, no, anong tawag natin dun sa part na may sira na 'yon? Yung sira na 'yon, ang technical term natin dun ay fault. Okay? F-A-U-L-T, fault. Okay? So sa transmission lines, fault yung tawag natin dun. So finifix natin yung fault. Okay? Kasi this is impractical to change everything. Okay? However, guys, all right? How would you locate, no? Nasaan ang fault? Okay, in your transmission line. Sobrang haba nun eh. Paano malalaman anong part doon yung sira? 'Di ba? Sa ordinary circuit, no, pag may naputol, alam natin saan yung naputol. 'Di ba? Kasi visually makikita natin. But if your transmission line is very, very long, no, how would you do that? No? So that's the purpose of our transmission line instrument na i-discuss ngayon, yung optical time domain reflectometer. No? So ang OTDR guys, no, ginagamit natin to no para ma-locate natin yung impairment o yung fault sa isang transmission line. Okay? So what happens sa optical time domain reflectometer is tinitake advantage natin yung special cases ng reflection coefficient. Naalala nyo ba guys yung special cases ng reflection coefficient? Meron tayong tatlo, di ba? Yung isa doon pag match. Pag match, ang reflection coefficient natin ay 0. So ano yung dalawa? Naalala nyo pa? Yung dalawang special cases ng reflection coefficient natin. So yung dalawang cases ng reflection coefficient, do you still remember? From our lesson last week. Di ba tatlo yun? Yung third one is pag match condition, ang reflection coefficient mo ay 0. No? So, okay. So, 1 tsaka negative 1, which is which? Yeah, that's the value no of the reflection coefficient. Pero alin diyan, no? Alin diyan yung 1, alin diyan yung negative 1. Okay? ZLI 0. So ano yung ZLI 0? Oh, what's the name of that, no? Oh. So that's the mathematical ano 'di ba term? Oh. So ano yung proper term natin? I mean, that's the mathematical number. ZL is equal to 0. If what? Okay? Okay, so yung reflection mo, pakibuo yung sagot, guys, no? Oh, paputol-putol eh. Oh. So, pakibuo yung answer. So, ano yung mga special cases ng reflection coefficient? Paki-construct yung answer nyo, no? Oh, paputol-putol, guys. Oh, so, ano yung tamang answer natin? Ano yung mga special cases ng reflection coefficient? Again, yung isa, yung third one is, di ba, if match, ZL equals ZO, ang reflection coefficient mo ay 0. Right? So, ano yung mga special cases? Yung 1, negative 1 values yun eh. No? So, ano yung yan, special cases? Mahalaga to guys, no? Don't forget that. Oo. Okay, shorted, open, load. What? Okay, hindi. Pag shorted, ano yung reflection coefficient? Pag open, ano yung reflection coefficient? Ayun yung hinahanap nating sagot. Okay, so sige, once again, no? Ano yung sa special cases ng reflection coefficient? Okay, so if shorted, okay, yan. Ito nga sinasabi ko, mali nga to, oo. Mali nga to, si Mr. Abelara. Maling, ito nga, hindi nga ZL equals 0, tsaka ZL equals infinity, hinahanap natin na term, no? So, what we are searching for is yung term na, pag ZL equals 0, ano yun? Okay, pag ZL equals infinity, ano yun? Right? Mathematical kasi yung ginawa natin na yun, no? So, basically, you just say na kapag may shorted, okay, shorted siya, negative 1 ang reflection coefficient. Tapos kapag open naman siya, okay, ano yung ating reflection coefficient? 1. Okay? Guys, mag-exam na tayo next week, no? Huwag niyo kalimutan yung mga ganyan. Okay? Alright. So, yung shorted tsaka open na yun yung fault, di ba? Yun yung mga possible types ng fault na meron tayo. So, dun papasok yung optical time domain reflectometer. Look at the figure, guys. So, what will happen is magpapadala ka ng pulse. Okay? And then, after some time, if you will receive back the pulse, tapos walang phase inversion na naganap, ibig sabihin nun, open yung fault natin. 'Di ba? Kasi 'di ba, ang ibig sabihin ng positive 1 na reflection coefficient is lahat ng signal mo babalik. Okay? Babalik, marireceive mo uli. Pag pinadala mo, marireceive mo uli. Okay, yung same signal mo without inversion. Okay, walang phase inversion. So, ibig sabihin, kung positive yung pinadala mo, ang marireceive mo, positive din. Ibig sabihin, pagka ganun, malalaman mo yung type ng fault dun sa transmission line mo. In this case, open. Okay? On the other hand naman, guys, no? Pag nagpadala ka ng signal, tapos ang na-receive mo is isang signal na same yung magnitude niya, pero phase inverted, ibig sabihin yung fault mo ay short circuit. Okay? Now, paano malolocate kung nasa yung fault? Kasi dito guys, sa optical time domain reflectometer is mame-measure mo yung time duration mula nung pinadala mo yung signal hanggang sa ma-receive mo uli yung signal. Okay, you'll be able to get the time duration. Okay? Ano ngayon kung alam mo yung time duration? Kasi yung time duration na yun yung time kung saan pinadala mo at nakabalik yung signal mo sa'yo. So pag alam mo kasi yung time and alam mo naman yung velocity of propagation in the transmission line, you can estimate the location of the fault. And you will also know what type of fault it is. Okay? So yun yung ano no, ibig ko sabihin last week no na magagamit natin yung ano no, magagamit natin yung idea no ng special cases ng reflection coefficient into something good, no? Which is yun yung principle sa optical time domain reflectometer. Okay? So we have a problem here, guys. Let's try to answer this one. A pulse is transmitted down a cable that has a velocity of propagation of 0.8 c. The reflected signal is received 1 microsecond later. Okay? So how far down is the cable impairment? Okay? So let's try to answer the given problem. Okay. So sabi daw dito guys, meron daw tayong OTDR na ginamit. So meron kang optical time domain reflectometer. Let's say guys, ito yung transmission line mo, no? So nagpadala ka ng signal. Then after 1 microsecond, na-receive mo yung signal mo, no? So actually hindi ito yung transmission line natin. Ito yung ito yung reading sa optical time domain reflectometer. So mula dito hanggang dito guys, ito po yung 1 microsecond. Okay? Now, what happens in the transmission line? Ano yung nangyari sa transmission line pagka ganun? Okay? So, ang nangyari is, nagpadala ka ng signal. So, pumunta dito yung signal mo. Nakita niya yung fault. Nakita niya yung location ng fault. So, ibabalik niya yung signal mo, marireceive mo uli. After 1 microsecond. So, ganun yung nangyari, guys. Okay? So, ibig sabihin, no, mula dito hanggang dito, ayun yung distance ng fault mo. Tama? 'Di ba? So, yun yung distance ng fault mo. So, sa normal na physics, ang formula ng distance is the velocity of propagation multiplied by the time. Tama? Kaya lang, 'di ba? Ganun yun, 'di ba? Distance equals rate times time. However guys, yung time na yon is actually the time na pinadala mo yung signal tsaka bumalik yung signal. So, ibig sabihin, ano yung kulang sa formula natin? 'Di ba? Kasi meron lang tayo dito guys, no? Velocity times time. That's the distance, 'di ba? Oo. So kailangan may divide by 2. Yan. No? Bakit may divide by 2? Kasi yung time na yun guys is the time it takes no for your signal to go to the fault and return back. So laging may over 2 dapat. Okay? So if that's the case, direct substitution lang. So ano yung VP natin? So ito given na guys, no, VP natin, the velocity of propagation is 0.8 c. Itong 0.8 c na to guys, okay, VF times c na to. Okay? Yan, VF times c na to. So bale, in this case, we have 0.8 times 3 times 10 to the 8. Okay guys, multiplied by t over 2. So ano yung time natin? 1 microsecond. So 1 times 10 to the minus 6. Okay, all divide by 2. Alright, so what will be our distance? Gaano kalayo yung fault natin? So we have 120 meters. So naunawan guys. Yan. So you have 120 meters. So may estimate mo ngayon na 120 meters, banda doon yung fault natin. Okay? So hindi mo iisa-isahin, no? Hindi mo hahanapin yung fault isa-isa, no? So that's the purpose of the OTDR, no? We use it no to locate the fault in a transmission line system. Alright guys? So very impractical kasi palitan yung buong wire. Ginagawa lang natin yun guys pag nagwa-wiring tayo ng ng power supply, di ba? O nagwa-wiring tayo ng mga simple electronics project. But imagine guys, no, sobrang haba nung transmission line mo, 100 kunyari 200 meters. So it's really impractical no for you to change everything, no? Kung may part lang naman doon na nasira. Okay? So yun. So that's the purpose of OTDR. Right? So next transmission line instrument natin is the slotted line, no? So ano yung slotted line? Basically, a slotted line is a short section of air-dielectric coaxial line with a slot in outer conductor through which a capacitively-coupled probe is inserted. It measures the wavelength and SWR of the line. So bali, mame-measure mo dito yung wavelength ng signal na nagta-travel sa transmission line. At the same time, guys, no, makukuha mo yung Vmax at Vmin niya. No? So naalala niyo yung standing wave niya. Do you still remember, 'di ba? If you get the Vmax and Vmin and you get the ratio, so ang makukuha natin guys is what? Ang masosolve natin is the SWR, the standing wave ratio. So, quick quiz nga kung naalala niyo pa yung lesson natin last week. What is the ideal value of SWR? Ano yung ideal value niya? Nye. Oh, so the ideal value of SWR is, yeah, very good. Ala, anong greater than 1? The ideal value of the SWR is 1. Okay? Ayan, no? So, bakit 1? Ano bang ibig sabihin ng SWR? SWR refers to the, ano, it shows the degree of mismatch. Ibig sabihin, if your SWR is greater than 1, mismatch. And we don't want that. No? So, ang SWR mo, ang best value niya is 1. Kasi pag 1 siya, ibig sabihin match ang load impedance sa characteristic impedance. Okay? Ito, grabe itong mga to. Kinakalimutan na agad. Last week lang. Oo. Huwag niyong kakalimutan, ha? Mm. So, o sige, sa ano naman, reflection coefficient, no? So, what is the ideal value of the reflection coefficient? Ano naman yung ideal value ni reflection coefficient? Zero naman. Hala, mali na naman. mali na naman. So, the ideal value of reflection coefficient is zero. Okay, bakit zero ang ideal value? Because if zero ang reflection coefficient, ibig sabihin walang reflection. 'Di ba? And pag walang reflection, okay, ibig sabihin match yung transmission line mo sa load impedance. O sige, next question. Oh. Yan, no? Ito yung mga tanong sa exam, guys, no? Ito yung mga possible na itanong sa exam. Oh, bawa ito. Ano yung range, no, ng SWR? Ano yung range ng SWR natin? Sige nga. Ano yung range ng possible values ng SWR? Okay. So yung range ng possible values ng SWR is greater than or equal to 1 or from 1 to infinity. Okay? Right? How about the reflection coefficient? What is the range of values no ng reflection coefficient? Pag reflection coefficient naman, guys, ano yung range ng values niya? So yung range ng values ng reflection coefficient, guys, is what? 0 to 1. Okay? 0 to 1, guys, ha? Oo. Eh, sir, ba't may negative 1? Eh, ano lang naman yun, di ba? Ang ibig sabihin ng negative 1, guys, is what? 1 din yun, di ba? Pero var angle 180. Okay? So, ang range niya is 0 to 1 talaga. Okay, guys? Yung negative kasi, it's just the angle. Okay? Vector quantity kasi ang reflection coefficient. Okay? So, bali yung negative 1, ibig sabihin nun, 1 var angle, 180. Okay? But if you're asked with the range, the answer is from 0 to 1. Okay? 0 to 1 yung reflection coefficient natin. Okay? O mga ganun yung mga tanong sa exam natin, no? So, please prepare. Okay? So anyway, let's try to answer this one, guys, no? So, game. Two adjacent minima on a slatted line are 23 centimeters apart. Kasi sabi ko nga, guys, no, ang slatted line, this is a device wherein you can see the voltage maxima and voltage minima. So in this case, sabi daw, yung two adjacent minima sa slatted line ay 23 centimeters apart. Find the wavelength and frequency of the TEM wave if the transmission line has a velocity factor of 0.66. Now guys, dito, gagamitin natin yung isa sa mga concept na tinuro ko last week. I don't know if you still remember that. Okay, so if this is your transmission line, okay, ito yung transmission line mo, may load siya. So for example guys, no, 'di ba may SWR to? Ay may ano to, may standing wave. If this is the location of your voltage maxima, okay? Where will be the location of your voltage minima? Okay? Yan, kung naalala nyo pa, no, yung lesson natin last week. Okay, so if yung kulay pink, that's the location of your voltage maxima. Doon mo nakita yung voltage maxima mo. So, gaano kalayo sa kanya yung voltage minima? And do you still remember? May concept tayo niyan last week, di ba? Na diniscuss. So bukod actually hindi lang sa voltage yan guys, sa current din. So kung yung current maxima mo, nasa yung current minima or impedance, no, yung maximum impedance and minimum impedance. Gaano sila kalayo sa isa't isa? Okay? Pagbalik na rin natin, no, para medyo mas akma sa problem natin. If this is the voltage minima and this is the voltage maxima, gaano sila kalayo sa isa't isa, guys? Hmm. Oh, 'di ba naalala niyo 'yun, guys? Anong concept 'yon? Oh, tama si Chucky T, no? So, pero anong concept 'yan? Ang tawag natin dito is what? Concept ng ano to, guys? May term tayo dito, no? So, yung distance nila very good is lambda over 4. No, hindi po half ng wavelength. So, anong concept natin dito? Bakit lambda over 4 yung distance between voltage maxima and voltage minima? May term tayo dun, di ba? Na ano, mula dun sa diniscuss natin last time. That's the impedance inversion. Di ba? So, impedance inversion yung term natin doon na every quarter wavelength, okay, nag-i-invert yung impedance natin. Okay, syempre kung mag-invert ang impedance mo, nag-i-invert din yung voltage and current mo. Di ba? So, that is the concept of impedance inversion. So, ibig sabihin, no, where will you find again the another voltage minima? Saan mo mahanap yung susunod na voltage minima? So, gaano siya kalayo mula do sa voltage maxima? If you're gonna follow the concept of the impedance inversion. So, where will you find, no? The voltage minima. Uy, kala ko ba na-guess niyo yung ano, impedance inversion? So, impedance inversion, di ba, once again, is ano, hindi, ba't lambda over 2? Wala. 'Di ba nga, uulit ano nga uli ang impedance inversion? So, ang impedance inversion is ano, the concept wherein every quarter wavelength nag-i-invert yung impedance mo. Eh syempre, pa mag-i-invert ang impedance mo, mag-i-invert din yung ano, voltage and current mo. O, 'di ba? So, ito yung una natin, 'di ba? Voltage minima. So, after lambda over 4, voltage maxima. Yung question ko, saan mo makutatagpuan yung next na voltage minima? So, I mean, what I'm asking is gaano kalayo 'to? Gaano kalayo itong dalawa, yung voltage minima at voltage maxima? Lambda over 4, 'di ba? Ayun nga yun, eh. 'Di ba? So, after lambda over 4, magbabaliktad uli. So, halimbawa, if you want to find the next voltage maxima, oh, so yung next voltage maxima, gaano siya kalayo dun sa voltage minima? Oh, lambda over 4 uli. Naintindihan ba? Oh, ba't hindi ano, ba't hindi naiintindihan? Nage-gets nyo ba? Okay. However, in this problem, we're not talking about voltage maxima and voltage minima. Anong sinasabi rito? Two adjacent minima. So, ibig sabihin, hindi mo papansinin yung voltage maxima. Di ba? Kasi two adjacent minima daw ang pinag-uusapan yung dalawang magkatabing minima. Okay? So, ibig sabihin, itong dalawang magkatabing voltage minima na to, gaano sila kalayo sa isa't isa? If yung nasa gitna nila is voltage maxima, na may distance sila na lambda over 4, 'di ba? So ibig sabihin mula dito hanggang dito, we have lambda over 2 na distance. Okay? Kasi ibig sabihin ng adjacent magkasunod, 'di ba? Or magkatabi. So yung dalawa magkatabi na voltage minima, sabi dito sa problem is 23 centimeters apart. So meaning to say, yung lambda over 2 po natin ay equal sa 23 centimeters. Okay? So ibig sabihin, no, what is our lambda? So yung lambda natin is 46 centimeters. Okay? 'Di ba? Kasi ang hinanap wavelength no? So, yung wavelength ng signal natin is 46 centimeters. Kasi the distance between the two voltage minima is lambda over 2. Okay? So, huwag niyo kakalimutan yun, guys, yun yung concept ng impedance inversion. Now, which is diniscuss natin last week. Okay, so from here, it's very easy na no to get the frequency of the signal. Okay, so anong formula natin again, guys, no, for the wavelength, no? So anong formula na gagamitin natin for the wavelength? Kasi isa-solve natin frequency so we need to get the formula of the wavelength. So anong formula ng wavelength, guys? So what's the formula for the wavelength? Delay ba? Ba't parang ang tagal yung sumagot? Hindi ko tuloy alam kung delay ba yung internet. Delay ba ako sa side nyo? Hello guys, delay ba? O hindi? Hello, hello. Delay po ba yung ano, yung lecture? Di naman. O ba't ayaw nyo sumagot agad? Di naman pala delay. Parang ano, parang ang ano nyo ngayon, malungkutin kayo ngayon. At parang malungkot kayo ngayon guys, no? Hindi kayo sumasagot agad. Alam naman din nyo alam sagot, kakadiscuss lang natin last week. Oh, so what's the formula for the wavelength, guys? Ano yung formula natin sa wavelength? 'Di ba, nakailang ulit ako nito sa inyo. Nasabi ko nga, iba yung formula natin ng wavelength, no, pagdating sa transmission lines. Oh, sige. So what's the formula for the wavelength, guys? Okay, so instead of C over F, we will write BP over F. 'Di ba? BP over F. No? So instead of C over F, that's BP over F. Okay? So what is our wavelength? We have 46 centimeters. So 46 times 10 to the minus 2. Okay? Equals, okay, ano yung velocity of propagation? No? So maraming formula yan. But if given ang velocity factor, so you can use CVF. No? So we have 3 times 10 to the 8, okay, multiplied by the frequency, by the velocity factor 0.66. Okay? Divided by the frequency. Alright, so what is the frequency in this case? Hmm. Tinitake note natin dito yung participation nyo guys ha. Hmm. Pag di kayo nagsasagot, di wala kayong participation. Okay, so we have what? We have 430 point, okay, 44, 43, 40, 435, okay, megahertz. Ayan. Alright. Okay. Okay lang. Yan. Huwag kayo masyadong malungkutin. Ba't malungkutin kayo ngayong araw na to? Ayaw nyo magsisagot. Oo. Dapat at least ano no, pagka nakita kitang ano, pag chinek ko to tapos wala kang ano, hindi kahit isang beses hindi ka sumagot, ano, may parusa ganyan. Bagsak na sa transma. Yan. Joke lang no, pero pwede rin. Joke lang. Okay? Dapat pa-participate kayo guys, no? Kasi mahirap tong, 'di ba? Pansin niyo naman, 'di ba? It's very hard no, the online class. So dapat you try to interact, participate, no? As if we are in the class, no? O yun nga guys, no? Malapit na tayo mag-exam tapos nakikinig ka lang sa isang video, no? Titingnan mo lang ano, hindi ka nag-interact, mahirapan ka. Okay? Sige. So now, let's go dun sa last example natin no for today's session. No, so answering a transmission line system. Okay? Transmission line system, guys. Alright, let's try this one. A lossy line with attenuation coefficient of 0.2 decibel dB per meter is used to connect a 50 watts generator to a 75 ohm antenna. If the line is 50 ohms resistive, no, solve for the power that is absorbed by the load. Okay? Kung hindi complicated yung problem natin, ano yung formula na gagamitin natin again pag hinahanap natin yung power absorbed by the load? Kasi yun ang question eh, 'di ba? Ang question sa atin is solve daw yung ano, power that is absorbed by the load. So yung P abs, no? So ano nga uling formula natin doon, guys? Okay, so what's the formula natin? Kasi P abs yung pinapasol, 'di ba? Oh, so power absorbed by the load. Kuya, ignore nyo muna lahat ng statement na nandiyan sa problem. Doon muna tayo no sa power absorbed by the load. So what is the power absorbed by the load? Anong formula yung gagamitin natin? Lahat ng mga to, kumanta-kanta pa ako last week eh. Tapos ito, hindi naman naalala. Di ba? Hindi yan. Hindi yan yung gagamitin natin dito. Di ba? So that's impractical formula. Pinahiya ko na nga sarili ko last week, hindi nyo naman naalala. Mga ano talaga kayo, bagsak na kayo lahat. Joke. Di ba? We're gonna use the 4SWR times 1 plus SWR, okay, quantity square, times the P incident. Okay? So this one, ito yung formula na gagamitin natin guys, no? Oh, so hindi natin gagamitin yung ano no, yung sinabi yung una, no? Because this is impractical in this case, no? So this one is the practical formula to be used, no, in this one. Okay? Oh, why? Okay, why? Because the SWR here is very easily calculated, no? So ano yung SWR natin? Mhm. So, dun sa problem natin, no, how can we solve for the SWR? So, sabi daw is, yung load natin ay yung antenna, tapos yung transmission line natin ay 50 ohms resistive. 'Di ba? So naalala nyo pa 'yon? Ano ba yung pag-compute mga formula sa pag-compute ng SWR? So ang load natin is 75 ohms antenna, tapos yung transmission line natin ay 50 ohm resistive, 'di ba? So pagka ganyan, you just get the ratio. I-divide nyo lang. So anong i-divide, sir? Ikaw bahala guys, no? Basta make sure na greater than 1 yung answer mo. Kasi nga, ang SWR, ang range niya is from 1 to infinity. So, kung ginawa mo kasing 50 over 75, di ba? Hindi yan. Hindi yan Gideon, no? Oo. Ito nga Gideon hindi nag-aaral ata. Oo. So, mali. Di ba? Kasi nga, pagka ang given sa'yo is both resistive yung load mo, okay? The SWR is just simply divide. Okay? I-divide nyo lang. Okay, guys? Nagegets? Kaya lang, dapat ang ratio mo, dapat, hindi siya assuming pure resistive. Pure resistive siya. Nakalagay naman, no? 75 ohms tsaka 50 ohms. Okay? So, automatic, you just simply divide, no? So, yung formula na yan, yung pag-divide mo, pwede lang gamitin kapag ka purely resistive. Eh nakalagay naman guys, 'di ba? Oh, dalawang purely resistive resistances 'yan. So, it's either 75 over 50 or 50 over 75. Ano yung tama? So, doon papasok yung knowledge nyo ng range ng SWR. So, yung range ng SWR natin is from 1 to infinity. Tama ba? Oh, so ibig sabihin, kapag ginawa mong 50 over 75, mali na yon. Because 50 over 75 is less than 1. Okay? So we have what? 75 over 50. Okay? So we have 1.5, di ba? Yan. So that is our SWR. Okay? So kung normal na problem to, you just directly substitute, no? I-substitute mo lang, no? Makukuha mo na yung ating power absorb. However, this one is a transmission line system problem. Okay? Kasi meron dito, no, if you're gonna read this one, okay, yung line natin hindi lossless. So, lossy line tayo na may attenuation coefficient. Okay? Kasi yung normal na scenario is, this is your generator. Okay? This is your transmission line, and this is your load. Okay? Parang ganyan yun, di ba? So ito yung 75 ohms na load mo, yung antenna mo. Alright. So ang mangyayari guys is yung signal natin, ito 50 watts yung ipapadala niya, di ba? 50 watts yung ipapadala niya. Ang assumption natin, kapag lossless transmission line, pagdating niya dito guys, no, sa load, 50 watts pa din. Okay? And then you can apply this formula, no? Yung 4SWR na formula, and you will be getting the absorbed power. Yan yung normal na nangyayari. However, ang transmission line mo kasi guys ay hindi lossless. Lossy siya. Okay? So, lossy siya with an attenuation coefficient of 0.2, okay? 0.20 dB per meter. So, what does it mean? So, itong P incident na to guys, okay, itong P incident na to, 50 siya dati kung lossless ang transmission line mo. But in this case, hindi na siya 50. Okay, there is a certain value here. Okay? Yan. So, yun yung kailangan nating malaman bago natin i-substitute sa formula. So, yun ang question. Paano natin malalaman yun? Okay? Ah, by the way, kulang tong problem ha. Paki-correct na lang dun sa ano yun, no? A 100 to, no? A 100, uh, 100 ba? 10. 10. 10. A 10 meter. Yan. Sorry, no? Kulang pala yung statement. A 10 meter lossy line. Yun, parang ganun. May 10 meter na word. Okay? So, ibig sabihin mula dito hanggang dito 10 meters. Right. So now the question is, how would you know, no? Ano yung P incident natin? Because yung P incident natin, guys, is hindi 50 watts. Okay? So, paano natin malalaman yun ngayon? Yan. In my experience, guys, no, of teaching this one, I always assume that the students already know this because this is a topic sa principles of communications. But in the years, no, that I'm teaching this subject, no, lalo na itong mga recent years, uh, pag binigay ko 'to sa exam, actually this is my past exam problem. Okay, walang tumatama. So lahat bagsak, no, sa unang exam. Majority, no, they fail. Okay? They know how to use the I swear formula. Alam nila paano gamitin 'to. Okay, kaya lang yung ginagamit nilang P incident ay 50. Okay, mali 'yon, no, hindi 50. Kasi yung 50 mo mababawasan siya because your line is lossy. And I was surprised, no, na hindi nila alam kung paano gawin 'yon. So kayo alam niyo kung paano? This is a topic in principles of communication, right? Because nag-aral kayo doon about dB calculations, no? Okay, so how would we get, no? Yung nasa question mark. What will be our correct P incident in this case? Okay, so we have this one, no? P incident times alpha times 10. No. Okay, so yan. Majority nga sa inyo hindi alam, no? Hmm. Sige, meron ba may alam? P incident times raised to alpha? No. Hindi. P incident times 10 raised to no. No. Eh, no? So I was surprised really, no? Na majority of the students don't know how to do it. Okay? In fact, this is a lesson, guys, no, in principles of communication. Convert dB to power. Okay, no? One common mistake, no? So another mistake, no? Hindi mo pwede i-convert ang dB sa power, okay? Because decibel is gain or loss, no? So gain yon or loss, so hindi mo siya pwede i-convert sa power, okay? Yan, another misconception, no, ng majority of the students. Oh, no? Yan, sige. How would we do it? Yan. Marami, no? So, lalo na dati, guys, no? Kasi ang transma ay fifth year. Okay? 10 log ng P incident. Okay, mali. Mali din, no? So, ayun, no? I was really, surprised that majority, tanong nyo, no? Lalo na dati, guys, no? Kasi kayo, third year pa lang kayo ngayon, eh. Okay, I'm out. Hindi, dati kasi mga fifth year na sila noon na although kasi kayo third year pa lang eh, no? So may time pa para baguhin yung pagkakatuto nyo, no? Yung mga estudyante ko noon, fifth year na guys, and they don't know this one. No. So nakakagulat, no? Kasi this is a topic in principles of communication. O sige, meron bang may alam nung totoong dapat na kung paano ginagawa yan? Kasi everyone, please pay attention to this because majority of our lesson will be anchored into this one. Okay, pagdating natin guys ng radio wave propagation, fiber optic communication, puro decibel kasi ang pag-aanoan natin eh, ang gagamitin natin. So dapat marunong kayo mag-analyze sa decibel. And what I'm seeing, no, from the students, they don't have any clue, no, about this one. Okay, yan. Sasabihin natin yung mali doon sa sinabi ni Rosette tsaka sa formula ni Papa Bear, sa binigay ni Gidjon tsaka ni Bieber, puro mali yan, no? So I will tell you, no, mamaya, no, kung ano yung tama. Pero baka merong may alam, no? So anyone? Anyone from the class? No, I will give plus points, no, sa exam sa may alam. Plus 5 sa ating prelim. Oh, malaki ng bagay 'yun, plus 5, no? Sa may alam kung ano yung gagawin. Last try guys. Wala namang mawawala, no? Kung mali, okay lang yun. Kung ang pinakamatalino sa klase nyo na si Mr. Papa Bear ay nagkamali, di okay lang magkamali din kayo, di ba? Di ba, na Papa Bear? Pag nagkamali si Pabs, okay lang magkamali kayo, di ba? Parang ganun. Sanay na, di ba? So, okay lang yun, no? So, try nyo lang, guys. Sayang din. Malay nyo, tama yung nasa isip nyo. Last try before I discuss, no? Ano ba tong decibel na to? Dali, last one. Walang gusto mag-try. Sayang yan, 5 points din, guys. Ano yung tamang gagawin? Yan. Wala. Dali, pag may nakapagsabi ng tamang gagawin, plus 5 points. Sa prelim exam. Paano mo malalaman ano tong mga nasa question mark na to? Hindi siya 50 watts. Okay, how would we know? Ayun, no? Sige, habang nag-iisip, no, yun nga sabi ko, no. Ayan, this is an exam problem, guys. Binigay ko to sa mga students ko. And napansin ko wala talagang tumatama kahit isa. Oo. And because no, hindi nila alam, no, yung concept ng decibel, which is something that you should have learned, no, sa Principles of Communications. Okay? Walang may idea. Okay, sige, no. So wala na magta-type na ang ano I mean, tapos na ang offer na 5 points. Okay. Meron kasing dalawa guys sa decibel na dapat alam nyo. Okay? The first one is yung dB lang mismo. So pag sinabing dB guys, no, pag decibel lang siya, so it's either gain, okay, gain or loss lang siya. Okay? Gain or loss lang yung pag sinabing decibel. Alright? Tapos, meron kasing tinatawag naman na power level. Ano yung power level? Dalawa yung power level natin, dBm or dBW. Okay? So, ang tawag natin dito ay power level. Okay? So, ibig sabihin, no? This is one of the mistake yung kay Mr. Rosete, convert dB to power. Mali yun. Because dB is gain or loss. You cannot convert it to power. Ang pwede mo i-convert sa power ay dBm or dB watt. Or on the other way around. So, yung power, pwede mo siya i-convert sa power level. dBm or dBW. Okay? So, yan yung mistake. Okay. So, ano yung mistake na doon kay Mr. Papa Bear? So, yung 10 log ng P incident, parang ganyan yung gagawin natin, kaya lang wala kang reference. Sa DBM kasi, meron ka dapat reference. So, ang reference ng DBM is 1 milliwatt at ang reference ng DBW is 1 watt. No? So, yun yung gagawin. Okay? Sige. So, the first thing that you need to do here, oops, nasama yung ground. Okay, the first thing that you need to do here, guys, is to get the attenuation. Kasi yung alpha, ano yung tawag natin sa alpha? Ano yung term natin sa alpha again? What is the term for alpha from our lesson last week? Last week pa yun no? So, ano yung term natin for alpha? Yeah, that's the attenuation coefficient We don't need that. What we need is attenuation. So, anong formula ng attenuation, guys? Anong formula ng attenuation? Yung attenuation lang mismo. Okay, alpha times the length, di ba? So we have 0.2, okay, dB per meter, yan, multiplied by 10 meters. So anong makukuha natin, guys? 2 decibels. Okay? So yung 2 decibels na yan, yan yung attenuation mo. Okay, next. When we say attenuation, is it a gain or a loss? Importante ba yun, sir? Yes, that's very important. Yung attenuation ba, is it a gain or a loss? Kasi dapat alam niyo yun. So, attenuation, ano ba yan? Gain or loss? Loss siya, di ba? Okay. Ano ngayon kung loss? Kasi sa computation natin, dahil loss siya, negative yun. Okay? Negative 2 dB siya, in other words. Naiintindihan po? So, kaya antenna gain. So, positive 2 dB kung antenna gain. Pero dahil attenuation, that is a loss. So, sa computation natin, minus siya. Okay? Minus 2 dB mamaya. The next step that you're gonna do is convert 50 watts into a power level. Okay? So, ano yung power natin no, in dBm? Okay? So ito yung sinabi ni Pabber kanina, 10 log daw ng P incident. Okay? Kaya lang, wala kasi siyang reference. You need to put a reference. So kung dBm, ang reference mo ay 1 times 10 to the minus 3. Ah. So anong makukuha? Okay? So yan yung mali doon sa sinabi ni Mr. Pabber, no? Wala siyang wala siyang reference kanina eh. Sagot niya lang 10 log ng 50 watts. So we have approximately 47 dBm. So ibig sabihin guys, no, etong 50 watts na to, no, this is actually equal sa 47 dBm. Okay? So that's your power level, 47 dBm. 49 ba o 47? Ah, okay. Nagkamali na ng type. Okay, so yung 47 dBm, so that is the power level dito saan? Power level dito. Ngayon, dumaan siya sa transmission line na merong ano guys? Merong 2 decibel na ano. Ano nga ulito? Ano nga ulitong 2 dB na to? 'Di ba? 47 dBm, dumaan siya sa transmission line na may 2 decibel na loss. So ibig sabihin, yung P incident natin, okay, in dBm, okay, is equal sa ano guys? 47 dBm minus 2 decibel. Okay? Anong sagot diyan? 45 dBm. Okay? So ibig sabihin pagdating dito guys, okay, 45 dBm na lang. At ito yung totoong P incident mo. Okay? Nagets? Kasi yung 47 dBm, yan yung sinend nung generator natin. But because your transmission line is lossy, okay, anong nangyari guys, nabawasan siya. Okay, so 47 dBm minus 2 dB. So 45 dBm na lang. Kaya lang, sa formula nung I swear, hindi mo pwedeng i-substitute sa kanya yung 45 dBm. So kailangan ibalik mo siya saan? Sa absolute. Okay? So ano yung P incident natin in absolute, no? So, bali 47 dBm, ibabalik mo lang. So that is 10 raised to 45, okay, divide by 10. Yan. Oh, times 1 times 10 to the minus 3. Okay? So, 'di ba ganun magbalik sa decibel? I mean, magbalik sa dBm to absolute, no? So divide mo by 10, 10 raised nung sagot mo times nung reference mo. Okay? So what is your reference? I mean, yung reference mo na 1 milliwatt. So what is your correct P incident in this case? So we have 31.62 watts. Okay? So ibig sabihin, hindi pala 50 watts yung nakarating doon saan. Hindi 50 watts yung nakarating doon sa load mo, but rather, 31.62 lang. Okay? Alright? Okay. So, hence, may SWR ka na, no? So, using the I-square formula, so we have P abs equals 4 times 1.5 okay, divided by 1 plus 1.5 quantity square multiplied by the P incident na 31.62. Okay, so what is your absorbed power? Ayan. So, yung ganyang concept, huwag nyo pong kakalimutan, no? Yung pag-analyze sa decibel. Okay? Because majority of our future lessons will be anchored to that, especially sa microwave wireless communication. Okay? So our answer is 30.36. Okay? So any questions po? Any questions, guys? Naintindihan nyo ba yung may sa decibel na part? Actually, ito yung mahalaga dito no? Kasi yung direct substitution line transman na part Okay? So yung transman na part, ito lang Di ba? Yung sa transman na part, ito lang. Direct substitution lang. So yung princom na part, no, dun kayo nagkakamali. Naintindihan ba? Okay, pag DBW, okay, ang reference ang magbabago. So sa DBW, pag DBW ang reference mo 1 watt. Okay? So may question dito, no? So paano daw pag DBW? DBW yung power level natin. So ang maiiba lang dito, guys, is yung dito, instead na 1 milliwatt, we will use 1 watt. So, ibig sabihin, 1 watt yung gagamitin natin dito. And we will be getting the same. Okay? So, that's the idea. No? Yung reference line magbabago pag dBW na tayo. Right? So, dalawa yun. Dalawa yung power level natin. dBm tsaka dBW. Siyempre, mas madalas gamitin si dBm. Okay? So, again, wag magkakamali, ang power, hindi mo siya pwedeng gawing decibel. Okay? Ang power, pwede mo lang siyang gawing power level. Ang gain or loss, sila yung ginagawang decibel. Okay? So, in this case, yan. Loss yan, di ba? Si attenuation. Okay? So, any questions pa po? So, expect a similar problem in your prelim exam with regards to this one. Okay? So, any questions po? Naintindihan nyo ba yung lesson natin? So, any questions, guys? May tanong ba? Hello? You're still there? Buhay ba bye, guys? Okay. Naintindihan nyo to, ha? Make sure that you understand this one. Okay? Because may ganyan sa exam. I'm telling you, may ganyan sa exam. Very similar problem. Mas marami lang hinahanap. Okay? Dito kasi, given na si 0.20 dB per meter, right? But it's possible na, ipapasolve pa sa yung attenuation coefficient. Something like that. Okay? Ayun. Yan, during the exam, yun, no? So, in my experience, guys, no? Lahat ng mga estudyante ko bagsak nung unang exam because they don't have any slightest idea, no? About decibel calculation. So, can you confidently say that you can solve decibel calculation problems right now? Can you confidently solve already? Naintindihan niyo na ba yung concept ng power level tsaka ng gain or loss? Kasi guys, gagamitin natin 'yan, no? Oh, nagagamitin natin 'yan sa sa fiber optic. Kasi next topic natin guys, fiber optics, no? Tapos gagamitin natin 'yan sa microwave, tapos gagamitin natin 'yan sa antenna. Okay? So, wala na question dito, no? So, naintindihan na. Okay, cheer ko kayo. Ba't hindi mo nagagets, Mr. Pababer? Hindi mo nagagets kung paano ginawa? Kasi ang power level, guess naman pala. Oo. So ang power level siya 'di ba? So kaya nga very very useful yung decibel calculation. Kasi sa 50 watts, yung 50 watts mahirap isipin kung paano siya naging 31.62. Gets nyo? 50 watts siya dito sa input natin, 31.62 pagdating sa load. Pero in terms ng decibel kasi, tsaka power level, it's very easy to see. 47 dBm, nabawasan ng 2 dB, o di 45 na lang. Okay? So pag may gain naman, plus naman yung operation natin. Okay? Alright. Okay, no? So, let's continue. Alright, so, okay. Now guys, you have your seat work today. Oh, pero wala pa siya, no? So I'll be distributing this, no? As in now, didistribute ko na siya ngayon. Okay, tapos paki-check later no kung nasa class notebook nyo na siya. So siguro after 5 minutes after the class, you may now check no kung nandun na siya. Yung ating seat work, right? So, ayan, pero ito yung seat work natin no as you can see in your screens. Yan. So, kung paano natin ginawa yung mga previous seat works, ganun din to, no? Yung seat work number 3 natin. Okay, so nagdi-distribute na siya, no? So, after 5 minutes after ng class natin, paki-check na lang. So, isang problem lang to, guys. 3 questions nga lang, pero madali lang to. Kayang-kaya niyo yan, guys, no? Okay. So, yeah, that's it, no, for this session. Okay, so stop recording now, guys.